So I'm starting it. I'm sharing my screen. Confirm if you're able to see. Those who have two devices, I have shared a DPP in your WhatsApp. You can have that open when we solve the problems, or else you can look from my screen also. So it's up to you. Okay. Now listen. So everybody knows what is a free body diagram. So I'm not giving much introduction about it. So what is a free body diagram? It is an isolated diagram. Right? What do you mean by isolated? It's a separate diagram drawn along with all the forces acting on it with their proper direction. Can I put it like this? Isolated force along with all the forces acting on it along with their proper direction is what is called as a free body diagram, right? And we all know that this is very, very important. This year also I would have used in many places. I would have told draw a free body diagram of this to understand, right? So I hope you have an idea about it. Now I'm going to discuss about few kinds of reaction forces that we know. See, when you have a block which is placed on a floor, what are all the forces acting on it?
mg.
So forces acting on whom? You're talking about the forces acting on the block or the floor?
Floors.
Okay. So if you talk about the floor, then what is the force acting on the floor? The block will try to exert a force of how much value?
G.
mg in the downward direction. And what will balance it? The floor will try to give a reaction force in the upward direction. Accepted? In a similar way, what will happen to this one? The weight of the block will act downwards, and at the bottom, this will start experiencing a reaction force, right? So one thing is clear: if you call mg as the action of the block, R will be the reaction offered by the floor on the block. So you're able to understand these two things. So this is a very, very simple concept that you people already know. Okay, next. Let us say there is a block which is placed on top of an inclined plane which has an inclination theta. Then what are all the forces acting on it? So when you draw a free body diagram of the block, I will draw the arrow marks. You people tell me what it is. So what is this arrow mark?
mg.
mg. What is this arrow mark?
R.
Sorry?
R.
This R, do you mean by... So here R means normal force. So everybody knows what a normal force is. Normal means perpendicular. So perpendicular reaction force offered by the surface of contact is called as the normal force. So here R, does it mean by normal force? So tell me, normal force should be perpendicular to what? The normal means perpendicular. Now. We are using in ray optics also. Normal means perpendicular. My question is, it should be normal to what? It should be perpendicular to whom?
Ground.
Surface of
Sorry?
contact.
it should be perpendicular to the surface of contact. If you observe, this force is not perpendicular to the surface of contact. Rather, this is called as a normal force. Okay. Then when you try to solve a problem, remember, I just want to explain a problem solving trick. When you're solving a problem on a horizontal surface, then you can take the bottommost point as origin so that any force on the right hand side will be considered along x direction. Similarly, you can take the coordinate axis, okay? Because whenever you're dealing with force is a vector quantity. Whenever you're dealing with vector quantity, directions are very important, right? So when directions are important, we need to have the reference axis in our hand. We need to have the reference coordinate axis in our hand, that is x-axis and y-axis. So any force that is acting in the rightward direction is positive, leftward direction is negative, upward is positive, downward is negative. So that is what we do when we have a horizontal surface. Now the question is, what are you going to do when you have a vertical, when you have an inclined surface like this? So when you have an inclined surface, listen to me carefully. You can take the reference axis in such a way that x-axis is along the inclination and y-axis will be perpendicular to the inclination. If that is the case, whichever force is not aligned along either x direction or y direction completely can be resolved into two components. Okay. Here, out of N and mg, which force is not aligned neither along x or y direction?
mg.
mg.
Mg, right? So what we can do to mg is mg can be resolved into two components. So when you try to resolve them, you should always resolve them along the x-axis and y-axis. So if that should happen, this point is taken as origin. Okay, then mg can be resolved into two components. One component, the horizontal component of mg, will be in which direction? Will it be down the inclined plane or up the inclined plane? This is down the inclined plane, this is up the inclined plane.
Down the incline.
Yes, it will be down the inclined plane, and the other one will be like this. So people know all these things, right? Now, question is, what is the force which is responsible, or which will at least try to put the object in the direction of inclined plane?
mg sin theta.
That's right. So mg sin theta, and this will be mg cos theta. So this angle is theta. We already know this, right? I have explained this concept when we saw what happens in a projectile motion on an inclined plane. Right? See, I just want to give you an extra information. This is a diagram we use to solve the problems which are for the problems where block and the wedge is involved. So sometimes what will happen is we might have to resolve the normal itself into different components. If that should happen, no? So if this is taken as, if this is a normal, now the question is, if I take this as the reference axis, this is x-axis, y-axis. If I take it like this, then out of the normal and mg, which one should be resolved?
Normal.
Now, how will you resolve the normal force? That's the question, right? See, for resolving the component, what I'm doing is one force will be like this. Okay. So, how to find the angle C? If this is taken as theta, now can I say this angle is also theta, vertically opposite angles? Then this will be n cos theta and this will be n sin theta. So, this is a concept which is used for banking of roads. Remember, at that time it will be helpful. Okay. I hope you are making a note of it. So this is used in banking of roads. This is used when you have a normal block and a wedge system. So these are some points related to normal. When we solve the problem, we'll see one more cases. The next is tension force. So where do we use the concept of tension? So tension is a reaction force offered by whom?
A string.
String.
Yes, it's a reaction force offered by string. Right? So now observe. When you have a string which is holding a mass m at its bottom, okay? The string is tied. So one of the ends is fixed to a ceiling and the other end, the block is hanging, okay? Now tell me, how will the tension act on this?
Upward direction.
Upward.
Okay, upward at which point? I'll give you 1 and 2. You people first tell me whatever you know, then we'll discuss.
So between 1 and
So
2.
if I draw a free body diagram of the block, then mg is acting downwards. So this is happening at point 1, okay? So here you have a string. What will the string try to do?
Pull it upward.
The string will try to pull it upwards. Let's say the tension at point 1 is T1. Is that all? What else is supposed to happen? What do you think will happen near the ceiling?
Sir,
Sorry?
normal force.
No. See, normal force will come into picture only when there is an object completely in contact. Here, it is like a point, right? A point is in contact. There will be no normal force. Rather, if at the bottommost point the tension is acting in the upward direction, at the other end it will act in the downward direction. Okay, where if I call it as T2, the string will actually try to pull the ceiling down. Okay. See, for you to imagine, I'll give you a simple example. Okay. Listen, this is a ceiling which is made up of iron. And let's say you have suspended a 5-kilogram block through a string, and the string is strong enough to hold it. Okay. Similarly, you have another string where, let's say I've given you a project, where that project has to be done using a thermocol. You have to use a thermocol. Where you're suspending the 5-kilogram block. Okay. Where the maximum capacity that this thermocol can hold is only 4.9 kilogram. What will happen? This iron can hold up to 50 kilogram. Let's have it like this. So what do you think will happen in each case? Now I'll put the question like this. Will the system exist? Exist in the sense, will it be without breaking?
Yes, sir.
First one will not break because you have maximum load holding capacity. What will happen in the second case? The ceiling will break. Accepted. The question is, if that has to break, one question I have in my mind is, I've used a string as a medium to connect it to the block. We have told that this can hold only 4.9 kilogram, right? When it can hold only 4.9 kilogram, how is this block able to exert a force on the ceiling as a piston? How is it able to transform or shift its positions of force to the ceiling? So what is happening there? The same thing. You're able to understand. I drew a diagram, right? Here. This T2 is there, no. This T2 is the one which is actually trying to pull the ceiling down. But if the ceiling is strong enough to offer a reaction force to overcome the tension, yes, it will not break. But if it is weak enough, like in the case of a thermocol, it is going to break. So what will happen is, if the string is the same, okay, if the string is the same, I'm repeating it. Okay, how many strings we use? We used only one string. If the string is same, and if the string is inelastic, or I can call it as inextensible. The string is inextensible, and if the string is massless, massless means its mass can be ignored, then what we can do is tension will be the same at its endpoints. Tension will be the same at its endpoints. So what correction should I do in this case if I consider it to be massless?
T1 is equal to T2.
Yes, T1 and T2 are same, provided the string is massless. But if the string has mass associated with it and if it is elastic, okay, then the value of tension will vary from place to place. How to deal with it, we'll see it in a problem directly. Okay. So most of the cases, when they say that there is a string that is existing, by default, the string is inextensible and the string is massless, unless it is mentioned in the question. Okay. Are you guys able to understand? So tension will be the same at its endpoints. So please make a note of this. Okay. Next. When you have a pulley system like this, when you have a string and a pulley system, I'll just take an example and solve this. Take this as an example and solve. Listen, there are two masses like this. Assuming M2 is greater than M1. Okay, I'm asking you to find the acceleration of this block or acceleration of each block. What will you say? Here, the pulley is also massless. Pulley is massless and it is frictionless. So how do we proceed, guys? For M1, if I draw the free body diagram, M1G will act downwards. Tension will act in the upward direction. What will happen in the case of M2? M2G will act here, tension will act. So T1 and T2. Is this right? Right or wrong?
Right, sir.
Sir, tension should be the same, right?
Tension is the same. Why?
Because string is assumed to be mass.
Yes. Secondly, how many ever see? Please make a note of this point. Right? This is a problem-solving technique. Okay. The number of strings in the diagram that is given, or the system, the number of strings in the system will be equal to the number of tensions. Here, how many strings are there? There is only one string that is connecting two blocks. So there will only be one tension. Had there been another string, like say, for example, if I have to extend this question like this, if I put it like this, then two strings, then the tension in the first string might be T1 and here it might be T2. Okay. Secondly, so M2 is greater than M1. So this right side, the block tends to go down and left side, the block tends to move upwards. Right? If this is A, here it is A. Okay. One more important point to be made noted here is acceleration of blocks will be the same if strings are inextensible. Had they been extensible, had they been elastic, again their accelerations will also vary. Okay. Now tell me how to frame the equation, guys. So for the first block, how do I write it? So it is moving in upward direction, right? Here all the forces are confined to y direction. So since the acceleration is taking an upward direction, the difference of which two forces should be equal to mass into acceleration. So can I write sigma Fy is equal to mass of the object into acceleration along y direction? So for the case 1, it will be T minus m1g is equal to m1 into A. Second case, you guys tell me, make it fast.
M2J minus T is equal to M2A.
That's right. So when you solve, T should get cancelled. Okay, so all these problems, tension will disappear in the mathematical equation. M1 plus M2 into A. So A will be equal to M2 minus M1 into G divided by M1 plus M2. So I hope you all know this, right? So whenever you have this kind of a block, what is the shortcut to write the answer? So we know that acceleration is nothing but net force divided by total mass, right? So what is going to be the acceleration here? What is the net force acting on it? So the difference of which two forces is making the system move. How much is the extra unbalanced? How much is the unbalanced force that is required for this system to accelerate? You can directly write it even without writing all these mathematical expressions. It is m2 minus m1 into g divided by the total mass. Okay. Now I'll give you a small question. You people tell me how to solve this. M3. So M1, M2 and M3. M1 is greater than M2 plus M3. So what will be the acceleration? Tell me in one step.
Sir, can you repeat the condition?
M1 is greater than M2 plus M3. You can look at the acceleration that is filling. So M1 is this. M2 and M3 are the other side forces.
M2
Yeah,
plus M3 minus M1 to G.
No. The reason I changed it. Can you repeat it?
M2 plus M3 minus M1.
No, it is actually M1 minus of M2 plus M3 into G divided by
M1 plus
M1
M2
plus
plus
M3.
M3.
Reason, see what I'm trying to say here is greater mass minus lesser mass into G divided by sum of all the masses. Because this is going to be the unbalanced forces. Unbalanced force acting on the system. The difference in those two forces, right? So like this, you have any number of masses in the system, you can directly write down the answer. I hope it is simple.
Sir, but I have a doubt.
Yeah, tell me.
Sir, but there will be different tensions, right, sir? But
They'll get cancelled, no? They'll get cancelled. See, I'll show you what will happen. To answer your question, see, if I draw a free body diagram of M3, that is the bottommost block, then M3G will act downwards, T2 will act upwards, right? What will happen on M2? On M2, there will be M2G, and it is connected to a string in the down at the bottom that will exert a tension of T2, and it is connected to a string in the top which will exert a tension of T1. Now you're able to understand.
Yes, sir. Yes, sir.
This is free body. Now see, M3G, or since the block is moving upwards, T2 minus M3G will be equal to M3A. Tell me the Newton's second law for this block, the M2 block. T1
T1 minus of T2 plus M2G.
M2G will be equal to M2 into A. When you add these two, here you have plus T2, here you will have minus T2. It will get cancelled. Similarly, this T1 will get cancelled due to M1. So nowhere tension will get involved. It will get cancelled provided those two conditions are satisfied. Is it clear?
Yes, sir. Clear.
Now see. So we'll directly do some problems. If any concept comes, that time I'll explain. So I've sent this document in your WhatsApp. Those who have two devices, you can look at it. If not, you can look at my screen. So there is a block of mass capital M that is pulled along a horizontal frictionless surface by a rope of mass M. So here the rope is having mass M. Okay. If a force P is applied at the free end of the rope, the force exerted by the rope on the block will be. See, now tell me how to do. So there is a block of mass capital M. You people try mass of capital M that is pulled on a horizontal frictionless surface by a rope of mass. So there is a rope of mass small m that is acting. If a force P is applied at the free end of the rope, the force applied is P, then the force exerted by the rope on the block is. So where will the force be exerted by the rope on the block? I'll give you a point, you people tell me. 1 and 2. How to solve, guys? I do not believe it's only one step. Tell me how to solve. The basic is free body diagram. See, since these two systems are connected together always, can I say both the blocks will have the same acceleration A?
Yes, sir.
Okay. If this is taken as P, now observe. Let's say the forces that will be acting here are there will be a reaction force acting at the contact. Because they are in contact, there should be some reaction force that is taking place. Similarly, there will be another reaction force which is trying to counteract the reaction force exerted by the rope on the block. Is this diagram clear? Now, how can I write the equation for the bigger block? Newton's second law says sum of all the unbalanced forces is equal to mass of the system into its acceleration, capital M into A. Right? So what about the second one? Sum of all the unbalanced forces. What are the unbalanced forces acting on it? P minus R is equal to small m into A. Guys, any doubt? So what can I conclude from this? If I add both, I'll get P is equal to capital M plus small m into A. Accepted. So A is equal to P divided by capital M plus small m. So what are they asking? What is the force exerted by the rope on the block? What is the force exerted by the rope on the block? That is R. So capital R is equal to what? M into A. So capital M into P divided by capital M plus small m. That will be MP divided by capital M plus small m. So this will be the reaction force. Okay. See, actually, you need not do all these things. Remember, whenever there are two blocks which are connected together, then the acceleration of the block or acceleration of the system will be equal to the force that is pulling the block divided by the total mass, capital M plus small m. Is that not what we got? So you could have actually saved time writing these steps. So what you could have done in the exam is you can directly take the acceleration, multiply the bigger block with capital M, and then you with the acceleration, and you will get the answer. Is that clear? So try to solve the next one. So there is an object of mass 50 kilogram is pulled by a rope of length 8 meter on the surface of a floor. On the surface by a force of 108 Newton applied at the other end. Okay. The force that is acting on the 50 kilogram mass if the linear density of the rope is 0.5 kilogram per meter. So what is the difference between previous question and this question?
Mass was directly given for the rope, but then here it's not given.
Okay, but is it possible for us to find the mass?
Yes, sir. Length is there, and then density is there.
Linear? Yes. What are we supposed to do to both?
0.5 is equal to mass by 8.
No need, see. Okay, we want to take it like that. 0.5 is equal to mass divided. It's just
Yes, sir.
multiply both, that's it.
Yes, sir. That's what I mean.
Multiply, you will get, yeah, 0.5 into 8, that is 4. So 4 kilogram is the mass of the rope. Now you can do the problem. It is the same thing except the fact that the previous problem, capital M is 50 in this problem, small m is 4, and capital P is how much? 108. Just use that like a formula, you'll get the answer. But what are they asking?
So is it 100 Newton?
How much? 100?
100 Newton.
Is it only 100?
Yes, sir.
Your voice is breaking. Yeah, that's right. So the force that is acting at P into capital M divided by capital M plus small m. So what is P? 108 into capital M is 50 divided by 54. So 54 into 2 is 108. So 100 Newton will be the answer. Okay, but don't remember this like a formula. You know how to solve it. That's why you used it like a formula. Okay, going to the next question. Do it fast. So there is a rope of length 15 meter and linear density 2 kilogram per meter is lying lengthwise on a horizontal smooth table. So smooth table, so there is no friction. It is pulled by a force of 25 Newton. The tension in the rope at the point 7 meter away from the point of application. This is where you need to be careful. Okay. So observe. All these problems, what you can do is you can treat them like blocks. So there is a rope of length, how much value? Let's call it as 15 meter, right? And it is lying on a smooth horizontal surface. It has a linear density of 2 kilogram per meter, guys. Okay. It is pulled by a force of 25 Newton. So capital F is equal to 25 Newton. The tension in the rope at how much distance? At a point 7 meter away from where? From the point of application. So 7 meter, let's say somewhere over here. What is going to be the tension in this direction? So how to solve this? So I told you, treat this like what? Blocks. So can I rephrase the question like this? It is like block of mass M1 and M2, where M1 is some part of the rope and M2 is another part of the rope, are like connected together. Now, recollecting the first problem, this was the rope, this is the block. Then there will be a tension acting here. There will be another tension that is acting here. Right? So how to solve this? So first, let's find out the acceleration. So how do we do? F minus T is equal to mass of this portion, that is M2 into A. Can I take it like this? Similarly, T will be equal to M1 into A. If I find the acceleration, I substitute it here, I'll get the answer. But my question is, we don't know what is M2. How will you find the mass of the system? So wherever linear density is given, you need to find the mass of a particular portion. You need to multiply that linear density with what?
7 meters.
Yes, that's right. So 25 minus T is equal to 2 into 7 into A. Similarly, T will be equal to how much, guys?
Thirty into A.
Why 30? M1 is how much? How much is a left out portion?
16.
Left out portion. Yes. Not 16. Huh? Oh, you're directly saying 16. It is actually 2 into 8 into A. That is 16A. Right? So 25 minus T is 14A. So what will you get? Acceleration as
25 minus T by 14.
25 by 30 Verma, 5 by 6. So what is the direct way to solve this problem? I have already told this. So acceleration is when two blocks are connected together, acceleration is equal to unbalanced force divided by the total mass. Total mass is 30 because there is a lambda into 15. Correct? So 5 by 6. So there are two ways to solve the problem. I've just given you two ideas. Guys, you're able to understand. 5 by 6 meters per second square. So what is the tension that is acting? T is equal to M1 into A, M1 order 16 into A is 5 by 6. But what are they asking?
So yes, sir, 40 by 3 will come. Then 13.33.
So how much is it? 40 by 3. Yeah? 13.33 is the answer. That's right. So I hope you guys understood. Right? So now we are a little bit comfortable with tension and the linear density based problems, because this concept will be used mostly in rotation mechanics also. You need to be very confident about it. Right? So I'm proceeding with the next problem. So next is very simple. You can do it in 1 minute. Please do it fast. There is a force of 100 Newton that acts in the direction as shown in the figure on a block of mass 10 kilogram resting on a smooth horizontal surface. So it's a pushing force. The speed acquired by the block after it has moved a distance of 10 meters will be. So if you observe, this is a combination of Newton's laws of motion and kinematics. So what are they asking? The speed, the velocity acquired by the block. The reason why they use speed is because it's going to be in the same direction. Direction is not changing. Acquired by the block after it has moved a distance of 10 meters. So how to solve this? So first, resolve this into components. 100. So this force will be 100 cos 30 and this will be 100 sin 30. Right? And there is 100 Newton acting downwards. So what is the unbalanced force that is responsible for the acceleration of this?
Hundred cos 30.
That's right. So 100 cos 30 should be equal to mass of this block, that is 10 into A. So A will be equal to this and this will get cancelled. 10 into cos 30 is root 3 by 2. 10 root 3 by 2, that is 5 root 3 meter per second square is the acceleration. Now what are they asking? Speed acquired by the block after it has moved a distance of this much value. So you have V, U, A and S. V is what you need to find. So use V square minus U square is equal to 2S. So V square minus 0 square, because they use the word resting, is equal to 2 into acceleration is 5 root 3 into the displacement is how much, guys? 10. So 10 into 10, 100, 100 into root 3, that is 1.7. 1.7 into 100 over 1700. 1.73
170.
into 100, 173 meters square per second square. This V square. So V will be how much? 173 means 169 is the nearest square root. Right? 169 is 13 square. So 13 point something should be the answer. Option is B. Here. I'm going to the next problem. So in the above example, the velocity after 2 seconds will be how much? Simple. V is equal to u plus at wherever time is involved. U is 0. So V is equal to U is acceleration is 5 root 3 into time is 2. So 10 root 3, 10 into 1.73, 17.3. So there you directly have 10 root 3. That's the answer. So they have told it in meter per second. See, these kind of questions, provided these root 3s are not there, you might get it in integer type questions also. Okay. So moving on to the next one. Now listen. Listen guys. So there are two blocks of mass 1 kilogram and capital M 2 kilogram that are in contact on a frictionless table. A horizontal force of 3 Newton is applied to the block. The force of contact between the blocks will be. So capital M and small m. Right. So did they say is applied to small m? There is a force of. See, these blocks have to move and you need to have a force of contact. Means the question is about the force of contact between the blocks. Then remember, the force has to be a pushing force. It cannot be a pulling force. So that's the reason I took a pushing force. Okay. So how will the free body diagram be? It is again similar to the first problem, to put it in simple terms. So what is the acceleration of the system? Capital F divided by
M plus M.
so small m plus capital M. So what will be the reaction force that is acting? So if I take the bigger block, this will be the reaction force that is acting. So R will be equal to capital M into A. So capital M into A, that will be capital M into F divided by capital M plus small m. So what is capital M? 2 into what is F? That is 25. How much?
3 Newton.
3. So 2 into 3 divided by capital M plus small m, that will be 3. This and this will get cancelled. Answer will be 2. Is this clear? Now listen. Now see. A force produces an acceleration of 5 meters per second square in an object, and the same force and acceleration of 15 meters per second square in another object. So the acceleration produced by the same force when applied to the combination of two bodies will be. So let's say there is a block of mass small m. Actually, it should be capital M because acceleration is inversely proportional to mass. Okay. Similarly, you have another block of mass small m. The same force is applied and it causes an acceleration of how much? 15 meters per second square. Guys, you're able to understand. Now, what will be the acceleration of the system when both these blocks are tied together and the same horizontal force F is applied on it? How to solve? So, A is equal to so how many unknowns are there, guys?
Mass of the two blocks.
So, mass of the two blocks. Okay, I'll call this as A1, A2, and A3. There are actually 3 unknowns. Capital F, capital M, small m. Right. So how to find them? How to approach? What is the idea you people are getting? We have only one law in our hand, Newton's second law, nothing outside.
Sure, we can find the individual masses using force and acceleration.
But we don't know force, no. But we don't know
So we
force
can
also.
keep it as an unknown quantity and then solve.
Actually, what we can do is, see, it's like solving the resistors in series. Okay. Or you can say capacitors in series, something similar to that. So we know that F is equal to capital M into A, or I can say F is equal to MA. So A will be equal to F divided by M. Can I write it like this? Or I will write capital M is equal to F divided by A1, and small m is equal to capital F divided by A2. Accepted, guys? Then what is A3 in the same logic?
F by
F
M
by
plus
M1
2.
plus M2.
Small m plus capital M, right? So what we can do is, I will write this as F itself divided by, in the place of capital M, can I write it as F divided by A1? In the place of small m, can I write it as F divided by A2? F will get cancelled. So 1 divided by A1 plus A2 by A1 A2. So that is A3. A3 will be equal to A1 A2 divided by A1 plus A2. What is A1 A2, guys? 5 into 15 divided by 20, it will be 15 by 4. How much is it? 3.75 is the answer. Right? So these kind of problems, we have to look at them mathematically, in the sense the number of unknowns and the number of equations that we need to free. How to eliminate a variable which is common in all the three. So here the common variable that we had was force. That is why I had to write in capital M in terms of force. Okay. Shall I move on to the next one? Now see guys. What is the tension in a rod of length capital L and mass capital M at a distance y from F1 when the rod is acted upon by two unequal forces F1 and F2, where F2 is less than F1 as shown in the figure? So the object will have the tendency to move in which direction, guys? Rightward or leftward according to the question?
Rightward.
Rightward, right? So it is again similar to what? It is like two blocks connected together. Right? So wherever there is a string that has, or a rope that has a mass associated with it, you need to start thinking in terms of linear density. So wherever linear density comes, you need to see linear density will be uniform. See, nowhere in the question it is mentioned. See, what is the tension in a rod of length capital N and mass M at a distance y from F1 when the rod is acted upon by two unequal forces? So when nothing is mentioned, why I'm stressing this is, see, I'll tell you. If linear density is constant, so what do you mean by linear density being constant?
Mass is constant.
Sorry, can you repeat it? Sorry, I didn't hear.
Mass is constant.
No. Mass will not be constant. It's not the mass being constant. Linear density, see, what we can do is, you have a rod much. If I break it into 1/3 of the portion and 2/3 of the portion, if I say the total mass of this is capital M, okay, then this 1/3 portion, let's say it has a mass of M1, and this 2/3 portion has a mass of M2. Now, let's say the total length of this is capital L. So if I ask you what is the linear density of the whole system, what will you say? I'm talking about the total
M by L.
capital M divided by L. If I ask you what is the linear density of the first portion, I'll take this as first and this as second. So what is the linear density of the first portion? 1 minute, 1 minute. I'll change it to M1 and M2. This is M1, M2 such that M1 plus M2 is going to be. So what is lambda 1? Now tell me. It will be mass of the first portion divided by what? 2L by 3, correct? Mass divided by the length of that portion. So what will lambda 2 be? That will be M2 divided by L by 3, correct? Are you guys able to understand this point? So when can I say the linear density of the system is constant? I've taken some random values, guys. Don't think much about the 2 by 3 and 1 by 3. Taken some random thing. So what do you mean by the uniform density of this rod? So listen carefully. This capital M by L, let's say it is coming out as 3 kilogram per meter. Okay. So if it is coming out as 3 kilogram per meter, for me to say that it has uniform density, what should this value numerically come out as? I'm talking about a number. It should come out as the same 3 kilogram per meter. And if this is also coming out as the value same 3 kilogram per meter, then I can say that it has a uniform mass density. Means you take any portion from the rod. Okay, you take any portion from the rod. If you calculate the mass of that portion and divide it by the length of that portion, if it is giving out a fixed numerical value, that is what we mean by uniform linear density or uniform density. Are you guys able to visualize it? See, there is reason why I'm speaking this much. I can actually solve the problem in one step and two. That's not the thing. I'm trying to stress on one point.
Understood,
You
sir.
give me confirm. Understood, right? See, whenever you have the concept of linear density, that is like whatever problems we did till now. So when I told you, you had this problem, 2 kilogram per meter. Here it is a uniform density. So whenever you have uniform density, the problem is very simple. If you need to find the mass of a particular portion, what are we supposed to do? What did we do till now? You just have to multiply the linear density with what? With
The length.
the length of that portion. Okay. Instead of this, had some questions will be like this: lambda is equal to 2 by 3x. Then what is the meaning of this? If they give you the value of lambda, where lambda stands for linear mass density, if they give you as 2 by 3x, now answer my question. Have they given you uniform density or non-uniform density?
Non-uniform.
Non-uniform density. Why? Because the value of linear density is dependent on distance. So wherever it becomes a function of something, okay, not only here. This concept which I'm going to tell you is throughout physics, and this is the way you're supposed to think also. Because most of the questions, at least in JEE, what we can see is they will try to twist the question to non-uniform. Okay, it again depends. I cannot be sure that they will give this question. If suppose that kind of a question comes, wherever you see non-uniform something, it need not be only linear density. Wherever you see that non-uniformity, the thing that is supposed to come to your mind is integration. There's a reason why I was stressing on this. Okay, so most of the people don't know where to use integration and where to just multiply and proceed. Okay, so are you guys clear with these points? Please make a note of it. Please make a clear note, because we will apply this kind of a concept in the system of particles when we need to calculate the center of mass of the system. they'll give you as linear mass density only. That time, they'll not give constant values, because constant values is a very simple thing. Everybody can solve it. They will wantedly twist it to non-uniform. That time, when I ask you, you people have to tell me that we need to use integration. This point should be in your mind. So to conclude the whole story, what I'm saying is, wherever it is uniform, I'm not talking about mass density alone. Wherever you see uniformity of a physical quantity, you can directly proceed with basic mathematics. Wherever the question of functions come, means wherever there is a concept of varying something, varying physical quantity, you need to start using calculus. If you understand this thumb rule, mechanics is very easy. Am I clear till this point? Yes or no, guys? I need some response. Am I clear? Is there any point that you
Yes,
are
sir.
not? Everyone.
Yes, sir.
Okay, next time when I ask you, see, I'll not tell all the story. You have to tell me whether I need to directly proceed or I need to use calculus. Now tell me, so I'm erasing all these things. Now tell me, in this problem, do I need to use calculus or directly I can proceed? Can I directly proceed or I need to use calculus, guys? So this is where you need to understand. If nothing is mentioned in the question, you can take it as uniform values. Okay, non-uniform, they have to mention it because we need a proper mathematical function to proceed. Or else you cannot use integration randomly. Or they should have mentioned that it is non-uniform, it is varying like this. You will form some differential equation mathematics, right? When a statement is given, you will convert it to mathematical form. Similarly, we'll do here also. So in this question, it is very simple. It is linear mass density. Okay. Now, you can ask me how to think. I've already given you the idea. How are you supposed to think? Wherever you have a rope with mass, break it into systems like the blocks are connected together. So if I draw a free body diagram, I'm coming from left to right. I'm taking the left word as first and the right word as second because F1 is greater than F2. That is the only logic, nothing else. So if I take this as F1, guys, this is T, then what is the linear mass density of the system? Lambda is how much? The values are given in the question. You people tell me. The basic question. What is lambda from the question?
M by L.
So capital M divided by L. So if that is the case, if I take the mass of the first portion as M1, what would be the mass of the first portion in terms of ML and other parameters? Uniform density multiplied. So capital M by L into what, guys?
Y.
That's it. Similarly, if I take the second block, tension F2, this is M2, then how much is this portion? This is L minus Y. This portion's length was Y. So what will be the mass of the second portion? Capital M by L into L minus Y. Correct? Now tell me how to find, what are they asking actually? They are asking T value, right? So how to find T? It's same again. So tell me the equation for the first block. F1 minus T is equal to M1 into A. F1 minus T is how much? T is T only. That's what we need to find. Capital M by L into Y into A. What about second case? T minus F2 is equal to capital M by L into L minus Y into A. Accepted? So find out A value. Once you find A, take that and substitute in any one of the equations that will give you the answer. So can you guys do it fast and tell me what is the answer? So actually, again, you need not do all these equations. Can you directly tell me what is the acceleration? I've already given you the shortcut. Acceleration is net force divided by total mass. So what is the net force, guys? F1 minus F2 divided by what is the total mass of the system?
Capital M.
M1
No, M1 plus M2 is what we have taken. It is capital M. That's what is given in the question. So
Yes,
take this
sir.
and substitute it here, or you can take and substitute it here. Whichever is easy, you will get the answer. Do it first. What's the answer? Da? It's a calculation going big. What's happening? Harish, what's the answer? M by L into Y into acceleration is F1 minus F2 divided by capital M. This is T. So if I take out F1 common, F1 will be equal to 1 minus Y by L plus F2 into Y divided by L. Is there an option like this? First one, right? Let's see. Did you guys understand what I did? I took out F1 common. 1 minus of M by L into Y divided by M. M and M got cancelled. So Y by L. So minus of minus is plus F2 into Y divided by cap. Again, M and M will get cancelled. So that's the answer. Okay, clear? Next. So one last problem for today. So there is a force that produces acceleration of 1, 1 by 2, 1 by 3, 1 by 4, so on, all in meter per second square, applied separately to n bodies. If these n bodies are combined to form single one, then the acceleration of the system will be, if the same force is taken into account. This question is similar to what? We did a similar question today. This is similar to which question? Is it not similar to this? There is a force which produces an acceleration of 5 meters per second, an acceleration of 15 meters per second. Then they're asking what is the acceleration produced in the combined system. Here, how many objects are there? There it was 2 objects, here it is n objects. So it will be easy for us if you are able to derive a formula for it. So if you observe this, I'm able to find that this is the acceleration. A3 is equal to A1, A2 by A1 plus A2. So can I say A combined is equal to A1, A2 by A1 plus A2 means 1 by A combined will be equal to 1 by A1 plus 1 by A2, accepted? Because see, had you, if you have capacitors in series, what will you have? C equivalent will be equal to C1, C2 by C1 plus C2, or 1 by C equivalent is 1 by C1 plus 1 by C2. So that's the logic. If there are n blocks in the system, then what will be the acceleration of the combined system? 1 by A1 plus 1 by A2 plus so on. What will be the last expression? 1 by An. So taking all this into consideration, they're asking that the acceleration of the system will be 1 by A combined is equal to 1 by 1 plus 1 by half plus 1 by 1 by 3 plus so on, and the nth one will be 1 divided by 1 by n. So what is this? 1 plus 2 plus 3 plus so on till n. So what is this? N into n plus 1 divided by 2, correct? So this is 1 by a combined. So what will be the value of a combined? 2 divided by n into n plus 1. Is there anyone having a doubt in this?
No, sir.
Good. So next problem onward, you can try it. So what I will do is, see, since I have given you the assignment, also this will be uploaded as DPP in today's task. Okay. You will have time till night 10:30. Try to complete this before 10:30 and upload it. If you have any doubts, you can let me know. You have the other number, right? You have the other number. You guys can message me, say, sir, I'm not able to solve this problem. So depending on the number of doubts, I'll clear it in the next class, or if it is only your doubt, I will immediately respond back to you. Is it clear? So from today, I'll be validating the PPP also. Make sure you're completing. Okay. So any other doubt from today's class?
No, sir.
Okay. That's good. So 1 minute.